This is, I'm going to be working through this worksheet. Again, working on simplifying expressions. We'll be dealing with expressions involving radicals and powers, and also the concept of combining like terms. And I will upload a version of this worksheet in the comment section below the video. So if you don't have a copy of it, you could get a copy of it. So anyway, here we are. Here we go. Simplifying each expression. So first of all, we need to make sure we understand what the word simplifying means. Simplifying means that we're supposed to write it in its simplest form, and we got to use all the things we know, like order of operations and the cumulative property of addition and multiplication, and our knowledge about how the exponential rules, and our knowledge about how square roots work, and our understanding of what like terms mean. So in this case, we're really faced with just nothing but multiplication, right? Even though there's two parentheses here, they don't really do anything for us. So really all we're doing is multiplying 2 times x squared times 4 times x squared times y squared. So it's just a bunch of things being multiplied together. When you're multiplying a bunch of things, you can do them in any order you want. So I'm going to multiply 2 times 4 first and get 8. I'm going to multiply x squared times x, whoops, that's supposed to be cubed. X squared and x cubed is x to the 5th. So I've taken care of that, and that, and all that's left is the y squared. So there's nothing I can multiply it by, so I just write it down there. Now remember that it's still multiplication, right? So our answer ends up being 8 times x to the 5th times y squared. Number 4 is very similar to this, so I'm going to hop down there. Same idea, but there's a lot more going on. So we can apply that squared to everything in here. So this is really the same thing as 14 squared times a to the 4th squared times b to the 6th squared. So I'm going to go ahead and do that. So 14 squared is 196. A to the 4th squared would be a to the 8th. And b to the 6th squared would be b to the 12th. Of course, all that's multiplied by this over here. A to the 6th to the 3rd is a to the 18th. And c to the 3rd to the 3rd is c to the 9th. But then I notice I can still multiply more things together. So I still have a 196 out front, but I can multiply a to the 8th and a to the 18th, and that gives me a to the 26th. And I can multiply b to the 12th times b to the 9th. That would give me b to the 21st power. Okay? So again, in this case and the case up here, nothing but multiplication, so I can do it in any order I want. And I really can ignore the parentheses. Down here, I couldn't ignore the parentheses right away because they had a squared on and a cubed on the outside of them. So I had to apply the cube and the squared first, then I could drop the parentheses. Okay, if we go over here, oh, here's another one just like that, so I'm going to do that one next. So in this case, once again, I can just drop the parentheses because there's nothing outside the parentheses that's making them important. So this is really just 7 times q to the 5th times 12 times q to the 3rd times r to the 5th. So we can multiply in any order you want. 7 times 12 is 84. Q to the 5th times q to the 3rd is q to the 8th. And there's nothing to multiply r by, so it's just r to the 5th, but it's still being multiplied. So that's when you have nothing but multiplication going on. Here we have nothing but multiplication going on, but there's some square roots involved. So first, one of the concepts we need to think about here is it's not considered simplest form to leave a square root with a perfect square factor in it. And so when you look at this, 12 has a perfect square factor in it because 12 is equal to 3 times 4, and 4 is a perfect square. So what I'm going to do is just write that 3 out here, and then I'm going to write a square root with the perfect square factors in it and with what's left over. So 12 can be broken into 3 and 4, so 4 is a perfect square, 3 is not. X cubed can be broken into x squared times x, where x squared is a perfect square, x isn't. So I'll put an x squared here and an x there. So now the reason why we're doing this is because I can take the square roots of those two things. So this is going to be 3 times the square root of 4, which is 2, times the square root of x squared, which is x, times the square root of 3x. Of course, 2 times 3 is 6, so I get 6x times the square root of 3x. Okay. Down here we have something entirely different going on. In this case, the parentheses do matter because there's something happening on the outside of it. So this little minus right here, these parentheses don't really matter because there's nothing out here that I'd have to do after I'm done with the parentheses, right? So, but this one, because that negative's out there, that means that negative has to apply to everything inside the parentheses. So I'm going to go ahead and drop the parentheses, but make the necessary distributions. So I can still write 12x minus 5. There's nothing different about it. But this becomes a minus 7x and a plus 11. And of course, there's just a plus 3x on here. So that negative applied to that guy and that guy. Okay, then I look for like terms. Well, I have 12x, negative 7x, and 3x. Oh, what am I doing? I have highlighters. Why not highlight? If you can, right? So there's 12x, there's a negative 7x, and there's a 3x. So all that added together would be what? 8x. And then we also have a negative 5 and a positive 11. Those can be combined together, and that gives me a positive 6. Perfect. Okay, we go over here. Again, we can't just drop the parentheses right away because they're being multiplied by something on the outside. So technically, I'm supposed to add these together first and then multiply by 4, but I can't do that because they're not like terms. I can't subtract 8 from 7x squared. So a way to get around doing the parentheses first is I can distribute, which means I have to multiply 4 times this and 4 times that. And I multiply 6 times this and 6 times that. Okay, so 4 times 7x squared would be 28x squared, and 4 times negative 8 would be negative 32. 6 times 5 is 30x. I'm sorry, 6 times 5x is 30x, and 6 times 10 is 60. But then we notice we have a couple like terms. I'll go ahead and bring in the highlight again. There's my like terms. The other two are not. So that would be 28x squared because there's nothing to add to it, plus 30x because there's nothing to add to that. But I can combine negative 32 and 60, and that gives me plus 28. Okay, here's another one of those things where I have nothing but multiplication, number 7. So I do have a little squared on that side of this parenthesis, so I'm going to apply that first. So 3 squared is 9, and y to the 6th squared is y to the 12th. And then we have x to the 5th, y to the squared, and z, because there's nothing outside this parenthesis, so I can just drop it. And let's see, can I multiply anything else? Oh yeah, I can multiply y to the 12th and y squared, so they have the same base, right? So that would be 9 y to the 14th, but then there's no other exponentials with base of x or no other z's. And that would be my final answer. Okay, b to the 50th, or the square root of 50, I'm sorry, I don't know where that came from. So the square root of 50 plus the square root of 32. So I can't add those together right now because they're not the same radical. So I have 1 square root of 50 and 1 square root of 32. There's nothing else I can do with that. However, I can simplify the square root of 50 because there's a perfect square factor in there. That would be the square root of 25 times the square root of 2. And this also can be broken into the square root of 16 times the square root of 2. But of course, the square root of 25 is 5, so that'd be 5 rad 2. Square root of 16 is 4, so that'd be 4 rad 2. And now I do have like terms because this is counting rad 2s and that's counting rad 2s. So I have 5 rad 2s here, 4 rad 2s here, a grand total of 9 square roots of 2. So that'd be my final answer. Okay, over here, once again, I just have a bunch of terms added up, but the parentheses don't really matter except for this little minus here. I have to distribute that. So first thing I'm going to do is rewrite it without the parentheses, but I have to do it legally. So that would turn that into a positive 3x squared, turn that into negative 4x, and that would turn that into a positive 7. Now I can look for like terms, and I'll bring in my highlighter for that purpose. Boom, 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 boom. And, ooh, bringing a purple color. Look at that. That's pretty. Okay. So as long as I'm doing color, I might as well go crazy, right? So if I add the two yellows together, I get 5x squared. If I add the two greens together, I get negative 7x. If I add the two 7s together, I get positive 14. That is my final answer. Okay, now we got some interesting fractional things involving powers. So first thing I notice is see if there's any common factors for the top and bottom. And I look in this one, there isn't. There's an S on the top and a T and R on the bottom, so I'm not going to get anything to cancel out there. So the only other thing we can see is this cubed out here. So this means that everything inside the cube is, everything inside the parentheses is cubed. So that means the negative 4 is cubed, the S to the 6 is cubed, the T to the 3rd is cubed, and the R to the 5th is cubed. So I'm going to go ahead and apply all those things. So 4 times 4 times 4 is 64, and a negative times a negative times a negative is a negative. So that'd be negative 64 on top. And S to the 6 times S to the 6 times S to the 6 is S to the 18th. And T cubed to the 3rd power would be T to the 9th power. And R to the 5th to the 3rd power would be R to the 15th power. And that's it. We just had to apply that cube and we're done. Okay? Now, in this case, I notice there is something I can cancel. So I could do that first. So in the inside, I could do, and there's still a negative 3 out here, I could write a negative 2x to the 4th. But that y, those y's will cancel with most of those, leaving just a y cubed at the bottom. Okay, but then I still have this negative 3 outside as a power. So keep in mind the negative exponent means that I take the reciprocal, or in other words, I flip the top and the bottom. So I could rewrite this as y cubed on top and negative 2x squared to the 4th on the bottom. But that cubed is still out there, but I was able to drop the negative now. Okay? So now I just applied the cubed like I did over here. So y cubed cubed, that'd be y to the 9th on top. And negative 2 cubed, that would be negative 8. And x to the 4th cubed would be x to the 12th. And that would be my final answer. Okay, here's another one where man, I seem to like cubes, I guess. So this is, again, you're just cubing everything inside. So you're going to get 8d to the 12th over 64e to the 3rd. Oh, but the 8 and 4, whoops, I could have canceled the 2 and 4 to begin with. That would have been a lot quicker, wouldn't it have? So this is actually d to the 4th over 2e to the 3rd. So I got rid of that 4. So now I just have to cube the top, which would be d to the 12th, and cube 2 in the bottom, which would be 8, and cube e, which would be e cubed. And that, my friends, is my final answer. That 12 does not look like 12. Okay? Okay, this is an interesting one. I think I'm missing a variable up there. I think there's supposed to be a w right there. For some reason it didn't come through in my printing. Okay. So I notice that there's a double w on top and bottom, and there's a v on top and bottom, but the v on top is in the wrong place. So the first thing I would do is write 16w to the 7th over negative 4wv v squared, because that negative exponent tells me it's in the wrong place. I just got to move it. Okay? So once I do that, now I can do some canceling and combining together stuff. First of all, 16 divided by negative 4 would be a negative 4. And w to the 7th divided by w would be w to the 6th. And then there's just nothing but v's in the bottom, so that would be v to the 3rd. Okay, over here we just have we're really just dividing a bunch of powers that have the same basis. So this a to the 5th divided by a squared would be a cubed on top. B to the 5th divided by b cubed would be b squared on top. And c to the 5th divided by c to the 4th would be just c on top. But notice there's a negative at the bottom. So anytime I divide a positive by a negative, I end up with a negative. So there'd just be negative up front. Everything in the bottom canceled out, didn't it? I guess I should square it to keep up my routine. Okay, once again over here, we could just add all this stuff, except for there's a 4 outside this parenthesis and there's a negative outside that parenthesis. So I'm going to have to distribute them. So that gives me 24x to the third minus 16x squared plus 28x plus 4. And if I distribute that negative sign through, that's going to be minus 4x cubed plus 2x squared plus 6x minus 1. Now I grab my highlighter and start looking for like terms. Man, this makes it so much easier to see. It's so fun. Okay, so I'm going to add the two yellows together. That would be, whoops. That would be 24x cubed and negative 4x cubed. That would be 20x cubed. Add the two blues together. That would be negative 14x squared. Add the two greens together. That would be plus 34x. And finally add the two, whatever that is, together. That'd be plus 3. And that would be my final simplest form. Man, there's another cube on the outside. Whoa, this is getting tiresome. Well, before I do the cube, I'll do some reducing. Clearly 8 will go into 24 3 times. T cubed will go into t squared. T cubed times. There's a negative there, and then all that's raised to the third power. So that would be 3 times 3 times 3. Well, actually, negative 3 times negative 3 times negative 3, which would be negative 27. And t cubed to the third power would be t to the 9th power. Awesome. Okay, this one's interesting. If you notice a shortcut, or if you notice something, you have kind of a shortcut here, because anytime you have two things underneath a radical, and it's multiplying or dividing, you can just combine them into one radical. So you could rewrite this as 2 times 20x to the 5th over 4x cubed. And why is that helpful? Because I can reduce 4 will divide into 20 5 times, and x to the 5th divided by x cubed would be x squared. Don't need that long of a thing. And of course there's still 2 sitting out there. Okay, now this is almost done, except for I can simplify the x squared, right? Because the square root of x squared is just x. So that is going to pop outside, and I'm left on the inside of the radical just a 5. Here's another one where I can't really just drop the parentheses because there's a negative. So I'll just make some adjustments and then drop the parentheses. Just distribute that negative through. And then if I grab my colors, looks like there's a squared x squared there. And looks like there's a number there. The rest of them are on their own. Okay. So that would be 6x cubed, and then minus 5x squared, and minus 3x, and then finally plus 2. Awesome. Okay, moving on to 19. So here, this whole thing in the bottom appears to be in the wrong place because there's a negative 1 outside. So this really just turns into 2x squared y times 6 times x times y. So I just, once again, have one of those long multiplication problems where there's a string of multiplication. We can do them any order we want. So 2 times 6 is 12. X squared times x is x cubed. And y times y is y squared. And that'd be all done. Over here, we have some negative exponents, so they're in the wrong place, so maybe we'll adjust that. And I can just drop the parentheses because I'm doing nothing but multiplication division, right? So I'm going to have x, y to the 9th, y squared times 7 times y on top. And on the bottom, I'm going to have 3 times 21 times x to the 5th. So now on the top, that x is going to cancel out, and it'll leave an x to the 4th on the bottom. The y's, and I'll have a 7 out front. And the y's are going to have 9 of them there, 2 of them there, and 1 of them there. So that's a grand total of 12 factors of y. So that'd be y to the 12th. And of course, oh, and this 21 actually will cancel that 7, so I'm going to get rid of that. Boom, boom, boom. That's a 1, and that's a 3. So I end up with a 9 on the bottom. Okay. Over here, wow, look at that. Once again, those parentheses aren't really doing anything for me because I can cancel anywhere when I'm multiplying, right? So I know that this x to the 4th cancels with that x to the 5th, leaving just an x. And the 7 cancels with the 7. And 4 cancels with the 12, leaving a 3. It's get a little bit messy, so I better write it down. 3xy times x times y squared on the top. And it looks like just y on the bottom. Okay, so I can cancel one more y. Wah! And that leaves me with 3 x times x, which is x squared, times y squared. That was a fun one. Of course, they're all fun. What am I saying? Okay, here, once again, I think like the number 2 we did, we're going to break this apart into 2 radicals. The radical full of perfect square factors and the radical of all the leftovers. So, for example, 27. 27 is not a perfect square, but 9 is. So we'd put a 9 here and a 3 here, because 9 plus 3 is 27. X squared is a perfect square, so I'm just going to put it in there, and there's no x's left over here. Y to the 5th is y to the 4th times y. And of course, z, I can't do anything, so I put it in there. And then I can go over here and square root all my perfect squares. So that'd be 3xy to the 2nd times the square root of 3yz. Over here, illustrating the concept that when you're multiplying 2 things underneath the square root, you can just multiply them and bring them into 1. So this would be 12x with the square root of the top of it. This is going to be 75x with the square root of the top of it. But then I can't add those together because they're not like terms, but I do notice that there's some perfect square factors in there, isn't there? So this is going to be 2 times the square root of 3x, and this would be plus 5 times the square root of 3x. Because 75 is 3 times 25, and 12 is 3 times 4. Okay. Now I notice they are like terms, aren't they? Because I have 2 of these things and 5 of these things, so I add them together, I get 7 of those same things. Okay. Number 24. Whoops, I didn't want to do that. Oh, I didn't know I could make it huge like that. Okay, so here we got a polynomial divided by another monomial. So this is kind of like 1 over 2x squared times 4x to the 4th. Actually, it's the same. It's not kind of like, it is this. So just like when I have a number outside multiplying, I can multiply this through. So I can take, but really what I'm doing is distributing the division through, right? So I have, technically I have 4x to the 4th divided by 2x squared minus 6x cubed divided by 2x squared plus 18x squared divided by 2x squared. And when I write it like that, it's pretty easy to simplify each one of these terms, right? So that would just be 2x squared. That would be minus 3x, and that would be plus 9. That's pretty sweet. And that would be my final answer. Here's the same idea. I'm dividing each one of these by 2x so I can distribute the 2x through. So if I divide this by 2x, that would give me 3 halves x, because the x's cancel out, right? If I divide that by 2x, I get 5 halves period. And if I divide negative 9 by 2x, this gets a little bit tricky, so I get negative 9 halves. And I could put the x down there with the 2, or I could just go x to the negative 1 out there. Okay. Here's a multiplying of two binomials. So the main thing is to remember you got to multiply everything in the first parenthesis by everything in the second parenthesis. So sometimes I draw lines to help me. 4x times 2x is 8x squared. 4x times 8 is 32x. Negative 6 times 2x is negative 12x. And negative 6 times 8 is negative 48. There's a few like terms there. Should I pull out my highlighter? No, it's probably okay. 8x squared. 12 minus, or 32 minus 12 would be 20. That would be 20x minus 48. Very nice. The 27 is really kind of the same problem because 3x minus 9 squared is the same thing as 3x minus 9 times 3x minus 9. So then we do the same thing, multiply. 3x times 3x is 9x squared. And 3x times negative 9 is negative 27x. But of course, negative 9 times 3x is the same thing, negative 27x. And then finally, negative 9 times negative 9 is a positive 81. Looks like we have some like terms here, so we'll go ahead and combine those. That'd be negative 54x plus 81. Okay. Okay, we got 3 more problems and we'll be done with this. This is a different, we talked about this in class, but this is now not, you're not being asked to simplify anymore, you're being asked to evaluate, which means you need to find out how much this expression is worth, which is impossible as long as it looks like that, but then they give us this inside information. So this says every x is equal to 2, every y is equal to negative 2, and every z is equal to 1. So I can rewrite this as 3 times 2 squared plus 2 times negative 2 all over 5 minus 3 times negative 2. And then I can simplify that. So 2 squared is 4 times 3 is 12 plus, nope, minus 4 over 5 plus 6. Of course, 12 minus 4 is 8, and 5 plus 6 is 11, and that's my final answer. Okay, do the same thing up here. It says x is 2, so hopefully forgive me for just hopping to 4, because 2 squared is 4, and y is negative 2, so that would be a negative 8 there, right? So remember, I think I said this in class, that absolute value symbols, that's what those things are. They are grouping symbols, so that means I have to do everything inside first. I can't apply the absolute value until after I've done the, until I've got just one number inside there. Okay, so then 4 minus 8, of course, is negative 4. But so now I can take the absolute value of that. Well, the absolute value of negative 4 is 4. There's my answer. And then finally over here, we gotta, we could probably do some simplifying first before we plug things in. So for example, we got to put that in the bottom, so I have a y cubed on top. And then I have a 9z squared x squared times 9x cubed. Okay, so I just squared this and put it on the bottom. And that's what gave me that. Okay. Now we just need to simplify. So that'd be y cubed on top. 9 times 9 is 81. And there's 2, 4, 5, 6, 7. 7 factors of x. Okay, that's the end of this video. Again, the best way to do this, I think, is if you've already done the worksheet, you can just come in and check it and watch it. You can actually speed it up if you want to see the answers, but I think it's helpful to hear the voice because I'm explaining kind of the nuances of each problem that we come across, and it's important for you to know those. So, happy viewing, and we'll see you later.